Good afternoon or evening, I guess. We're going to work on the Unit 3 review for your test coming up. So we did these today in class, but we're going to touch on them again. I would suggest you pause the video and see if you can write them in, but if not, watch it all the way through and write them down afterwards. So the first one says the segment from vertex to midpoint of opposite side. Remember, your keyword is midpoint. So that is the median. So visually what that looks like, and I'll erase this later. If I have a triangle, I need to find the midpoint of the opposite side and connect it to the opposite vertex. So the markings we need to include are those two hash marks to say that it's the midpoint. Okay, now a different picture would look something like this. Oops. Ignore that last line there. There's my thing. The midpoint of this side would be here, so notice that it's not perpendicular at all. The only thing you know is that it's congruent on both sides because that's the midpoint. Right? The next one says the line that divides a segment into two equal parts and is perpendicular. So divide segment into two equal parts, you should think bisect. It's the bisector. And the last piece is perpendicular. So this one is the perpendicular bisector. Now visually, if I have a triangle, I find the midpoint, and it's also got to be perpendicular. So notice it does not have to cross through the vertex. It just has to be perpendicular and be congruent. It does not have to cross through the opposite vertex, right? The next one says the segment from vertex to perpendicular of opposite side. That's the altitude. So unlike the perpendicular bisector, it doesn't have to cut the side in half. It has to just go, ooh, that doesn't look perpendicular. Ooh, oh, that's going to be bad. Hold on. Altitude. If I have a triangle, it needs to go from here perpendicular to the opposite side. Notice that's clearly not the middle, so that's how an altitude differs from a perpendicular bisector. Right? The next one says the ray that divides an angle in half. So keyword, it divides an angle in half. That's called an angle bisector. Okay? The intersection point, or it's also called the point of concurrency of the three medians. You should think median means middle, so that's the centroid. The intersection, also known as the point of concurrency of the three altitudes of a triangle, is that funny orthocenter. Right? The intersection of the three angle bisectors is called the incenter. Okay? And remember, the incenter has a triangle with a circle inscribed on the inside. Okay, so the incenter has something like that. We can call that two things. We can say it's a triangle with a circle inscribed, or it's a circle with a, it's a circle, let me think that through. It's a circle on the inside of a triangle, okay? The last one, the point of concurrency of the three perpendicular bisectors, is called the circumcenter. And it has the opposite thing that's true. Okay, it's got the triangle with the circle circumscribed. So the circle's all around it. That's why it's called the circumcenter. So the incenter has a circle inside the inscribed or inside the triangle. The circumcenter has the circle outside the triangle. That's why it's called the circumcenter. Okay? So we already did these in class. This is a perpendicular bisector construction. This is an altitude. This is a median because it crosses the midpoint and then you connect to the opposite vertex. And perpendicular bisector is the same construction, except notice it doesn't have to go through the vertex. It's just the segment that's perpendicular and is the middle. Okay, so we're going to go over your checklist, your white packet. All right, so first we're going to start off with marking. Mark the following diagram according to the statements given. So E is the midpoint of AB, and a lot of students do this. Well, great, I know that's a point. I already labeled it as E, but the point of E is the midpoint. That means that AE is congruent to EB, so I need those markings. Don't just put a point. That doesn't help at all. All right, the second one is a little tricky. We did this in Unit 2, but that symbol right there means parallel. And it's saying AB is parallel to DF, and parallel will look like this. Two little arrows signifying that the lines are going in the exact same direction, meaning they have the same slope. The other upside down T means perpendicular. So it says EF is perpendicular to CD. So I go to EF and CD, and I have to put a box. You could have put it there. You can put it there. It doesn't matter. You don't need both. You just need one. Right, and the last one says that DB is an angle bisector of angle ADF. Now remember how we label angles, ADF. So the angle we're looking at is highlighted in red right there. This DB segment is an angle bisector, so that means we know that ADB is congruent to BDF. Make those two markings, okay? The next one says draw. And you can see I have the ruler and the protractor here because I'm allowed to use those when it says draw. I'm not allowed to use those when it says construct. So I'm going to start off with my ruler. When I want to draw parallel lines, I can start by just drawing a straight line, right? Now they need to be 4 centimeters apart. So a lot of you are going to turn your ruler and go, oh, I got it. I'm just going to draw it in. Well, we need to ensure they're parallel. So I'm going to use my protractor to make a 90-degree angle. So I'm going to mark my 90 up there. Now I can take my ruler and turn it. And notice the parallel lines, oh, need it to be straight. The parallel lines are going to be 4 centimeters apart. So I'm going to line up my ruler. I'm going to draw a segment that's 4 centimeters, right? Now I've drawn now 2 segments that are perpendicular, but I need to draw parallel lines. So I've got to move this down because I'm a little short. So hold on. I'm just going to get our words away for now. So we're drawing parallel lines. I don't know what that's there for. All right, so I know that this is 4 centimeters, and I know these are perpendicular. The next thing I need to do is to draw another 90 degree up here. So I'm going to turn it sideways. Mark my 90 degree. Now the thing is about this, I don't need to make sure that my segment is any certain length because it doesn't tell me how long the parallel lines need to be. It just says they need to be 4 centimeters apart. So I'm going to now make another perpendicular line. Okay, and since we've made 2 perpendiculars, that means these 2 lines have to be parallel because they have to have the exact same slope since they're both perpendicular to a single line. So those 2 lines are now parallel. Right, the next one I'm going to do is draw a scalene triangle. So I'm going to need to erase this. So if you need that back, we're on the video. Okay, so to draw a scalene triangle, I'm going to start by reading it. Angle XYZ is 44 degrees. XY is 2 centimeters, YZ is 3 centimeters. So I'm going to start by picking one of the segments. So I'm going to draw a segment that is 2 centimeters. I'm going to make XY first. Oops, what happened to my ruler? Hold on. Fix my ruler. Now it's going the right way. I just need centimeters. Right, so I'm going to draw one that's 2 centimeters. Right? This is segment XY. Right? Now I can't draw the other segment in yet because I need to do the angle. And notice it says XYZ. So that means I'm going to go from X to Y to Z somewhere up here. Now I have to measure that to be 44 degrees. But the point of me doing that is showing you that Y is your vertex. All right? So that's where I'm going to place my protractor when I go to make the 44-degree angle at Y. So I'm going to place my protractor here. Get a little bigger so I can read it. Promise after this it'll be a little easier. It's these tools that take me forever. So I'm going to go make a 44-degree angle. And since I'm swinging up, I need the outer region. So that's where 44 is. Okay. So now I'm just going to make a segment. Did I have that lined up? Okay. So now I'm going to make a segment from here out to there. Right. And then the next piece I need is my YZ. So hold on a second. The next piece I need is my YZ. Sorry, I'm having a lot of short people problems with this board today, so I'm having difficulty reaching things. So I'm going to take my ruler, and I need to measure 3 centimeters. Oops, that's backwards. I can't stand these rulers. I need just a regular one. Wait, I'm going to measure 3 centimeters from Y on the ray. Okay, so there's my 3 centimeter mark. Last step now is to connect from there to my last point, X. So I've now constructed triangle X, or drawn triangle XYZ. This is my 44-degree angle. It's my 2 centimeter segment. This is my 3 centimeter segment. Now what's often helpful is to use your protractor to measure the other angles. So I'm going to do that, but I'm not going to record it. I'll show you at the end. So I'm going to measure them. You go ahead and measure your angles real quick. Okay, so with my silly tools on the SmartBoard, I got 100 degrees and 36 degrees. You can tell me if those are accurate or not. I'm using SmartBoard tools, so I'm not sure how accurate they are. But just note that once you're done drawing the triangle, you should measure the other angles on the other side. Right? So now we're on to constructing. Hopefully I can do a little bit quicker and better at this. So to duplicate a segment, I'm going to start with my starting point. I take my compass. I'm going to measure the width of AB. And then I go to my starting point, I make an arc, and I can pick any point on that arc for it. So I'm going to pick there. Last step, use your straight edge to connect those 2 points together. Okay. So there's my segment. It's always helpful to label it, so I'm going to label it AB. Right. Next one is the one you're going to want to watch the most. It's duplicating an angle, so I'm going to do it down here. In this case, you don't start with a point. I make a point, but I want to start with just a ray that's extending off that point. So I'm going to start with my ray, and why I call it a ray is because it really could go on forever, but mine doesn't. So to start this, I'm going to go to my original angle and make an arc any size I want. I'm going to go down to my new one and do that same arc. So it's identical right now. The last piece I need is to measure the width. So I'm going to go from intersection to intersection. Right, so I'm going to measure from here to here. I'm off my screen. Okay, and I'm going to go down here and measure the same width and make an arc. And then that tells me where I draw my arc at. So I'm going to use my straight edge, go right through that. And I've now duplicated the angles, so these 2 angles are now congruent. Right. The next one says construct triangle ABC, so it's congruent to, oh, that IK shouldn't be there. Construct triangle ABC, so it's congruent to triangle DEF. Okay, so first step. This one goes, you're just going to do the duplicating a segment 3 times. You make a starting point. Okay, so I'm going to make my starting point here. And you can pick any one of these you want to duplicate first. So I'm going to go over here. I'm going to do FE first. So I'm going to measure FE, go to my starting point. I'm going to make an arc. And I can pick any point I want to be E. So this is F, this is E. Okay, and then I'm going to use my straight edge to connect. So I've gotten one side of my triangle. The next step is to copy the other 2 segments. So I'm going to measure DE next. Right, so I go down here. Now I'm going to start at E, so I need to flip this around. I'm going to mark an arc at E, and that tells me that D is somewhere up there, but I can't pick a point because I got to get it to line up with the other one. So I'm now going to measure FD. Okay, well, that was lucky. I'm going to go over to F. I'm going to make an arc. And notice they intersect. Where they intersect is where my last point is. That's where D is. Now, I've labeled them with the originals just so you can see how I copied it. But really it told us to make triangle ABC congruent to DEF. So A is the same as D, so I'm going to change D to A. B is the same as E, so I'm going to change E to B. And C is the same as F, so I'm going to change I'm going to change F to C. Okay, so that's my duplicated triangle.